Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to stop our discussion and study of polynomial functions and move on to a discussion of just any function in general and pretty much end our chapter 2 on this topic. It's going to be function transformations. It's going to be flipping epic, I promise, and it's not going to be too difficult. So, without any second thought, let's go. Okay, so firstly, what do I mean by function transformation? So what we mean by transforming a function is just by altering the output or the input in a certain way to change the graph and to change the equation of the new function. And we're going to be looking into the first instance of that, which is very interesting. And we're going to be finding the equations of the new functions and maybe doing some problems with them. Anyway, so to start with here, I've just got a just general graph of a random function, y equals f of x. F of x could be any general function, doesn't matter what it is. And here is a random graph I just drew of a random function. And the first transformation we're going to deal with is taking from y equals f of x, and we're going to transform this into y equals f of x plus some number a. So let's think about what that means. We're going to take the original function, and to all the output values for each x, we're going to add the same number to each of the outputs. So let's think about what that would look like on our graph. So for example, this output right there, we're going to take the original output and we're going to add some number to it. In this case, let's say we're doing f of x plus 2. We want to find out, if we take the outputs and we add 2, we want to find out what the transformed function looks like and what it is. So if we think about it, if you take the original output and you add 2, well, you're just going to move it up the y-axis by 2 units. Similarly, if we take this output here, which happens to be negative, and then we're just going to add 2 units to it. Boom, bada bing, bada boom. And that's going to happen to all the outputs along the x-axis there. And I'm sure you can see, it's not too hard intuitively to see what's going on here, is that if each and every single output is being shifted up by 2 units, then that's going to move the whole function as a whole uniformly up by 2 units. So it will end up looking something like this. As you can see, the entire function has been moved up just 2 units of space. And that is the easiest function transformation. It's very intuitive, and it's not too hard. I'm not going to dwell too much on it. But yes, to recap, we're transforming the original f of x into f of x plus 2, where all the outputs get the number 2 added onto them, and it ends up shifting the graph up. Or in the case, if you were subtracting a number, it would shift the graph down. And that is very easy. So let's go on to the next transformation. Okay, so this next transformation is a little bit harder and has a bit of a strange intuitive output when we look at it, but nevertheless, let's get into it. So this next transformation is we take the original function f of x, and instead of altering the outputs by adding something each time, we're going to add a number to the input x for each input x and see what that does to the function. Make your predictions now. Will it go up and down again? Will it scale the function by a number? Will it shift it left to right diagonally? Who knows? Anyway, to get some intuitive feel for this and to understand what it does, I'm going to actually use a specific example. So for example, consider if we go from the graph y equals x squared, and then we alter this function as to y equals x plus 2 squared. So what we're doing is we're adding 2 to each input and then squaring it and putting it through the function. So the original x squared graph looks a bit like this. Nice parabola, just touches the x-axis at 0. Now, let's go and think what happens if we take plus 2 to every single input. So let's draw another graph. We don't have it just touch there. Right, so first of all, let's start at 0. So let's see what happens if we plug in 0 to our new function. Well, we're going to get 0 plus 2, so 2 squared, so it's going to be out at 4. Now, let's look at negative 1. Oh, negative 1. If we take a negative 1 plus 2 and we square it, we get 1. So, cool, that's just going to be a nice little 1 there. Now, let's look at negative 2, for example. Negative 2 plus 2, 0. Squared 0 is 0. So, boom, there's our new minimum point. Okay. And we can do similarly for negative 3, and we'll get positive 1 again. And let's do it just for the number 1 to be nice. 1 plus 3, 3 squared. This new function at the number 1 will output 9. Okay, so now if we connect the dots to draw the line and see what the continuous function looks like. It looks like the same function as before, but it's been shifted across the x-axis by some number. And what number, you might say? By 2 units. As you can see, the point where 0, or a point where I used to touch the x-axis, now touches it at -2. It's been shifted 2 units. The point on the original parabola, x equals 2, outputted 4. But now, x equals 0 outputs 4. So you can see that the graph has been shifted -2 units along the axis, which is a bit strange, right? If you knew it was going to shift the function, you'd imagine it was shifted to the right because it's positive. But no. What adding 2 to the input does is kind of like delaying the input by 2 units, shifting the function along the x-axis, which is pretty crazy. So that's what that function does. Now let's try and find the equation of the new transformed function after we've moved it 2 units to the left. And we can just expand that out and get x squared plus 4x plus 4. And that's crazy. Try it out yourself. Go on Desmos or your favorite graphing calculator. Mine's Desmos. Plug in y equals x squared and you'll get that lovely parabola. And plug in y equals x squared plus 4x plus 4 and you'll see an exact copy of the parabola just shifted 2 units. So there we go. That was our second function transformation. Just adding a number to each single input x, and what it ends up doing is shifting the function along the x-axis by that number of units, but in the reverse direction to what you'd think. A nice handy rule I like to think about is that if you've got a function transformation that affects the output, for example, like the last one we looked at, that it will affect the function along the y-axis. But if you have a transformation that's affecting the input and not the output, it will shift it along the x-axis. And you can think of that like, well, the y values are like the outputs. So if you affect the outputs, you'd think it would move along the y-axis. And the x values are the inputs. So if you affect the input, you'd expect it to move along the x-axis. And beautiful. That is the 2 function transformations I'll be covering in this video. Just a quick little video. There'll be a part 2 to this video where we do just the 2 harder function transformations. I look very forward to seeing you then. Goodbye. Hope you enjoyed the video. That was Hamblin. Peace.